We are going to learn how to solve a system of equations using a matrix. So, what is a matrix? It's not the movie, even though I love the movie, especially the most recent one. It is actually an array of numbers. So, all these numbers are organized by rows and columns. So this is going to be helpful when you have 2 or 3 or 4 systems of equations with multiple variables. You won't get into that until Algebra 2. I took a class in college called Linear Algebra, and I used matrices whenever we had like 5 different variables. Like it was an A, a B, a C, a D. And so you're trying to find the solution. What is the value for each one of those variables? All we're working with right now is an X and a Y. We have 2 variables. We have 2 equations. So this is going to be helpful whenever we have our equations in standard form. So I'm just going to refer back to this. Remember this one? That wasn't very fun because we had to solve both of them for Y and put them on a graph. So it required a lot of work. So matrices will help us be able to use it in the standard form that they're in, that AX plus BY equals C, to be able to solve for our X and Y without graphing. We just use our calculator. What you'll learn in Algebra 2 is 2 other ways of solving systems. You won't necessarily be given the chance to use matrices. You might be told to do elimination or substitution. So you'll have to use those. But matrices will be a way to check your work. Make sure you get it right. All right, so first step is to write your equation in standard form. So that is the AX plus BY equals C. Oh, let's talk about rows and columns real quick. Those are always confusing me. These are your rows. Columns, think about like in Greece, they had beautiful palaces with columns on them. These are your columns. They're the ones that go straight up and down. They're the vertical ones. So rows are across, columns are up and down. So this is called a 2-row by 3-column. We can put this in the calculator and it can simplify it for us. So there's actually row operations that you'll learn in Algebra 2 about how to solve this by hand. But what we're going to do right now is to learn the shortcut. We're not going to learn solving it by hand until Algebra 2. So you do need your calculator. Get to the home screen, clear out the home screen. So you're going to take your standard form equations and just write the coefficients of the equations in matrix form. The word coefficient means the number in front of your variable. So if you have it in AX plus BY equals C form, then you're going to write this as A, B, C for the first equation. And then the second equation, you're going to do the A, B, C. No operations. Unless there's a minus, then you're going to put your coefficient as a negative number. So you'll write your coefficients in matrix order, and then we're going to follow these steps. So let's go ahead and do this example. So these are written in AX plus BY equals C form. So we're going to write this with the coefficients. If there's no number out front of the X, then it's a 1. And then the Y would be -2. And then the C is 2. So that's row 1. Row 2 would be 3, 1, and 6. So we've done step 1. It was already in standard form. Step 2, write the coefficients in a matrix. We did that. Step 3 tells us what steps we do. So it says second x to the -1, which that says matrix. It's hard to see because my printout is not very good. So that should say matrix. So if you look at our calculator, see how x to the -1 is matrix? So we're going to do second matrix. And it comes up to this. Select math. So arrow over to math. And go down to B, which is RREF. And what that means is row reduced echelon form. Not really significant right now, though. So RREF, not REF, because that's just row echelon form. We want, or reduced echelon form. We want to row reduce it completely. So make sure you do RREF. Push enter. And it comes out to this on our calculator. Okay, next step says alpha zoom. Alpha zoom. See the zoom button? That's the matrix options for us. What kind of matrix do we have? 2 by 3. 2 row, 3 column. So we're going to have to arrow up and then go over to the column, push enter, so that it's now selecting that 3. So this one, see how this one's like sideways, but this one's up and down? Same thing. This was just a different operating system. This might be how yours looks on your other calculator. Okay, so then we're going to go down and push OK. So see how it says select the size of your matrix, 2 by 3. OK, push enter. Now it pops up a template for us to fill in. You won't push enter till you're done filling in that template. You are going to arrow over to get to each one of those numbers. Change all the zeros to the numbers that we need. So we have 1, -2. Remember, we're arrowing over. Can't talk. 3, 1, 6. You can close the parentheses, or you can leave it open. On this one, since we're only doing one operation, it doesn't matter. I want y'all to check each other. Show each other your calculator before you hit enter. Everybody check. Show each other. If you're not sure, ask somebody for help. You've got to go up. See how it's selected on OK? Go up, 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 up. Go over, and down. We're going to go push enter. And then go down to OK. There you go. Now you have all of the spots. The template. No. Can you help him get his? Does that calculator work? have the same options. Did it look different? But it's still the same concept. Was everybody able to do it?
No color. I like color.
Are y'all able to do it?
I like color.
You only have 2 by 1. You have a 2 by 2. You guys like 2 by 3. How did y'all do? Did y'all get it? Did y'all get it for everybody? Okay. I think the trickiest part is switching it from a 2 by 2 to a 2 by 3. You have to arrow up, arrow over, select, then go down and hit OK. All right, now push enter and look at how it gives us our solution. All right, so I'm going to write the solution here. I gave you the output here. I gave you the exact picture of it. So it should be 1, 0, 2, 0, 1, 0. So let me tell you what that means.
No solution.
Nope, it means there is a solution. It would be, if it was no solution, it'd be like, it would give you an undefined or it'd give you all zeros. It's something funky. So what it does is it'll give you your solution just like this. And you'll have a number in the last spot. And what this means is, remember AX plus BY equals C? So this would be 1X plus 0Y equals a number. That tells us what X equals. Then the other ones, if I were to plug it back into the standard form, 0X, that doesn't matter, 1Y equals a number. That tells me what Y equals. Then you can write your solution as a coordinate pair, X, Y. So then on this one, it's telling us X equals 2 because this is AX, BY equals C. So the X value, there's no Y value, so the X value equals 2. Then down here, 0X, BY equals C, Y equals 0. So the solution to my system is 2, 0. Is that a little bit easier than solving each one for Y, graphing, finding your solution? The reason we would use this is anytime it's written in that standard form. It makes it where we don't have to solve for Y. All right, so we need to just practice this. That's the best way to get better at it and go through those steps. I want you to clear your calculator right now. Second plus 7, 1, 2. And I'm just having you do that so that you can run through all your steps again. I'm just having you do that one time. You don't have to do that every time. I'm just trying to get y'all to work a little harder. All right, let's look at the next one. Quiet down. Solve the systems using matrix. Write the solution as an ordered pair. So on each one of these, I want you to write your matrices and then write your solution. You don't have to write anything else. So I'm going to write, it's written in AX, BY, C form. As long as it's written like that, we can just write our coefficients. So this would be 4, 3, 24. Then 5, -8, -17. Now, use your steps to solve the solution. and get your answer in terms of x, y. So look back over here. It says second matrix. If you want to follow along with me, I'll go slow. Second matrix. Over to math. You can go down to RREF, or you can actually go up to get to it quicker. And then the next step says alpha zoom. Alpha zoom. It's a 2 by 3 because I have 2 rows by 3 columns. So go up and over to columns 3. Then go down and hit OK. Then it gives me the template. Fill in my numbers. If there's not enough spots, that means that you didn't select the right size. You got to go back and start again. So write your solution. 3, 4. So on these problems like this, the only thing I'm requiring you to write is the original matrix and your solution. You don't have to write anything else unless you have to solve. All right, go to the next one. Make sure they're not trying to trick you. Make sure it's in the AX BY equals C form before you just go and write. Did I do something wrong? Oh, look at that. I selected the wrong one because it's not all the way reduced. See how it isn't 1, 0 a number? It didn't reduce it all the way. So I got to do it again. How many of you think I did that on purpose?
You do.
Yes.
I didn't do it on purpose.
It's easy to select the wrong.
Yeah, it is. But it was good. It was a good learning experience, right? I'm trying to teach.
You know, if you select alpha and then B, it'll take you straight to RR.
Ooh, that's a shortcut. I like it. Very good. All right, so this one comes out to 5, 1.
Is this the worksheet?
There's another.
The 2x.
So the ones on the right side of this foldable are going to require a little bit more work. They're not just in ax plus by equals c. Okay, I did the last one on the left side, 13, 30. So x is 13, y is 30. That's what that means. Yeah, you got to move things around. So look at this one. See, it says y equals half x. If I see one like this, it might be easier just to solve the other one for y, but it might not. So what we would want to do is get this to say ax by equals c. So we have y equals half x. We wanted to say ax by equals c. So we need to get the 1/2 x to the other side. Just subtract 1/2 x. So now we have negative 1/2 x plus y equals, there's nothing left. So I put a 0. So all I did was move it to the other side and put a 0 for my c because I have nothing left. Also, it doesn't matter which equation you put on top.
Can we use it as a decimal?
Yeah,
You can use that as decimal. I think you can put it in as a fraction, can't you? You should be able to. Yeah, you can put that in. You are going to have to delete that 0 that they have in that spot, though. For some reason, it leaves that. Four, 2? All right, let's look at the next one. It's not written in ax plus by equals c. So, yeah. So this would be like 0x plus y equals negative 6, right? We can't move an x over because there is no x. So this negative 6 is actually your c. ax by equals c. So it's 0, 1, negative 6. They actually gave us part of the answer, didn't they? They gave us the y value. 4, 1, 2. Two, negative 6. Which we already knew y was negative 6 because they told us that in the very beginning. All right, last one. First one is fine. It's the second one that's not. Subtract 3x on both sides. So then we have 6, -2, -4, -3, 1, 2. Oh.
Yeah, mine.
So this came out to 1, -0.3 repeating, -0.6 repeating, 0, 0, 0. It didn't give us an error. It gave us just this. So what it actually is this is the exact same line. So that means all real numbers or infinitely many. It's the exact same line. So parallel lines are whenever you come up to, so that's all real numbers, whenever you have a number here and you have all these zeros. So all these zeros means it's either the same line or it's parallel. I didn't give an example of parallel, but whenever you have parallel lines, it's going to look like this. 1, some number, 0, and then 0, 0, 1. So it's going to have 0, 0, 1. So you know how it's supposed to say 1, 0, 1, a number? It's going to have a 1 at the end. So this is no solution. All right, so you have an assignment to do of using the matrices. Yes, go ahead and glue that in.